Okay, dear students, now let's continue with the question one. In the second part of the question one is we need to draw the signal G2 of n. Again, we need to multiply the signal x of n, which we already plotted in the previous question, and we need to multiply it with u2 u n plus 2 minus u of n. So it means we need to first of all try to plot this signal, that how it looks like, then we are going to multiply it with the x of n here. So let us plot the signal. Let us plot the signal un plus 2 minus u of n here. Now, as I told you previously, that u of n is nothing, but it will start at n equal to 0. This will be 1, then it will be all the impulses will be 1 till the positive n here. Okay, this is your u of n here. Now what we need to do here, first of all we need to say that what is u of n plus 2. U of n plus 2 means I need to shift my signal left by 2 here. If I shift my signal to the left by 2 here, so what it will be, it means the sample at 0 will move to minus 2, the sample at 1 will move to minus 1, the sample at 2 will move to 0, sample at 3 will move to 1, the sample at 4 will move to 2, like this on the positive side. Okay, it will continue here. So this is nothing but this is your signal this is u of n plus 2 here. Okay, now what we are interested in finding u of n plus 2 minus u of n here. Now this is your u of n, this is your u of n, this is your u of n minus n plus 2. So we will perform this signal minus this signal here. Okay, so what we are going to get here, basically we are going to get this resultant signal as simple. All the values here are 0. All the values, I mean, let's suppose it minus 2, this all values here are 0. So 0 minus 0 will give me 0. Okay, so at minus 2 the amplitude is 1, so 1 minus 0 will give me 1 here. At minus 1 the sample amplitude is 1, so 1 minus 0 will again give me 1 here. So at minus 1, now at 0 this is 1, so 1 minus 1 will give me 0. Then at 1 it is again 1, this is again 1 here, so 1 minus 1 will give me 0. So you know that all the sample values here are 1, this is all our sample values here are 1, so 1 minus 1 will be 0. So it means I'm going to get only 2 sample and all the remaining values here will be 0 here. Okay, all the sample value here will be 0 here, and this is your u of, let me write it here maybe, u of n plus 2 minus u of n here. Okay, so we were able to find this u of n plus 2 minus u of n here. Now what we will do, we will take this signal and we will subtract it from the signal x of n here. So now let me draw it here. Now we will take the signal and we are going to multiply it with x of n here. Okay, so let's suppose this is your n here, and it is at minus 1 I have 1 here, at minus 2 I have 1 here. Okay, so the resultant signal is n. It's quite clear that at minus 1 this amplitude is 1 and 1, so 1 multiplied by 1 will give me 1 here at minus 1 here. Similarly at minus 2 the amplitude here is 1, or the sample value here is 1 for x of n. At minus 2 the sample value here is 2, so 1 multiplied by 2 will give me 2 here. Okay, all the remaining values here are 0, and all the remaining values here are 0, so 0 multiplied by anything will give me 0 here. So basically 1 multiplied by the signal x of n, and I will get the sample amplitude which are multiplied with 1 here. All the remaining values which are 0 will give me 0 here. So this is basically your signal G2 of n here. Okay, brothers? Okay, now let's move to the next question. The next question is we need to plot the signal G3 of n here. G3 of n is basically multiplying the signal x of n, which we already plotted earlier and which I have shown you right now, multiplying the signal with delta of n minus 2 here. So let us first discuss what is delta of n here. Delta of n means this is a unit impulse function here. What is a unit impulse? Basically, unit impulse means, for example, I am going to have only a sample value at n equal to 0, which is equal to 1 here. All the remaining values here will be 0 here. Okay. So now basically we are given delta of n minus 2 here. So it means I need to move my impulse to the right by 2 here. So it means my impulse will move at the position 2 here, maybe, like for example, let's suppose this is 1 and 2 here. So this is your delta of n minus 2 here. Okay. So I will take this sample or this signal delta of n minus 2 and I need to multiply it with x of n here. So if you see here, just to plot it here, simple, I'm going to have a sample which is like 1 here at 2. So this is what I have basically. Okay. So it's quite clear that at 2 I have 1, at 2 I have 2 for x of n. So my resultant sample will be basically my signal uh, which is here at 2 I will get 2 here. Okay, so this is your G3 of n here. Okay, clear with this? Okay, this was a question solved graphically. Okay, now if we observe this question carefully here, it involves basically any given signal x of n which is multiplied with some impulse function here. Okay, shifted impulse or impulse, whatever. So in this case, whenever we have a situation like this, we can use the properties of impulses also here. Okay, you should have studied the properties of impulse, which is basically sampling property here. Okay, let me write here. It is sampling property here. Property of impulse. Okay, sampling property of impulse here. What is the sampling property of impulse? Sampling property of impulse tell you that if I have a given signal x of a here, for example, I have a given signal x of n here, and if we multiply the signal with some impulse here, for example, delta of n minus a, for example. Okay, so this will be basically equal to x of n and at the value of n equal to a into delta of n minus a here, and which is basically equal to x of a into delta of n minus a here. What it means? It means that basically whenever I multiply a signal with some shifted impulse, I'm going to get the same impulse at the same position, but the value of impulse will be the value of the signal at that particular constant shift value here. Okay, so now in this case, if you observe here, what he said that we are told that basically uh, the value of a in our case is 2 here, if you see from the question here. Okay, so it means I'm getting the signal x of 2 into delta of n minus 2 here. Delta of n minus 2 is nothing but the same signal here. But what about the amplitude here, the signal amplitude value? This will be the value of the signal at n equal to 2 here. And the value of the signal at n equal to 2 is 2, so it means my sample amplitude will become 2 here. Okay, like what we have here. So we can also solve it using the properties. Okay, whenever we have a signal multiplied with some impulse, we can use the sampling property, or we can use the properties of the impulses here. Okay, so this is one way of doing it, and I think in our tutorial, maybe most probably the question 3, we are going to solve it using the using the properties here. Okay, thank you.